So our next lesson here is on the different types of chemical reactions. Now let's do a little bit of review here very quickly about chemical reactions, just because it's been a little bit of time. We have to remember that chemical reactions are written this way. So we've got the reactants on the left-hand side of the arrow and the products on the right-hand side of the arrow. So what we're going to be doing in this section is actually looking at the reaction as a whole and classifying them or categorizing them based on what's going on with both the reactants and the products. And what we're going to do is we're going to go through the four basic types of chemical reactions. The first one that we're going to look at is synthesis. And synthesis is defined as two or more simple substances that combine to make something that is much more complex. Now, in general, with synthesis, energy is released because we have new bonds that are getting formed. And our example reaction is one that you are familiar with. H2 plus O2 gives me H2O and then energy. Now, we don't technically count energy as a product because it's not matter, obviously. Okay, now when we are looking to identify reactions as synthesis reactions have only one product. What does that mean? Well, if I'm looking at them actually counting, this H2 here counts as one reactant. This O2 here counts as a second reactant, and I can tell that here because of the plus sign. Remember, we don't count energy in this. So we have one product here. The only thing that is made from this reaction is water. And that's what when you say one product, that's what you're looking for. And that tells you it's synthesis. The second type is decomposition. In decomposition, we have a complex substance that gets broken down into substances that are more simple. In general, with synthesis, or with decomposition, it's kind of the opposite of synthesis. We take energy because we have to break bonds. So our sample reaction here is the decomposition of mercury oxide. So I have mercury oxide, we add in energy, and I get mercury and oxygen. If I'm looking at a reaction and trying to classify it as decomposition, we see that we have only one reactant. So again, we take off energy, it doesn't count. We have one reactant here, my mercury oxide, and I have two products, the mercury and the oxygen. The third type is single replacement, because sometimes I have things that aren't either synthesis or decomposition. Single replacement happens when an element replaces another element of the same type. So if it's a single element and it's a metal, it will go into the compound and replace the metal. If it's a nonmetal, it will go in and replace the nonmetal. This always involves an element and a compound. So let me show you the sample reaction. So I have zinc plus hydrochloric acid giving me zinc chloride and hydrogen. So if I go in and I count, I have one reactant, two reactant, and then I have one reactant, or one product, two product. So it can't be synthesis or decomposition because I have two different things on both sides. Now I have to actually go in and analyze what the substances are. Zn. I know that's an element because I only have a single chemical symbol, one capital letter here. HCl is a compound, and I can tell that because I have at least two. On this side, I have a compound, two symbols, and an element. Now I know it says two on the H's there, but remember we only have one symbol, so it's only one type of atom. So I have an element plus a compound, giving me a compound plus an element. I have one of each on both sides. That's very, very typical of single replacement. The last type is double replacement. And double replacement happens when two compounds switch partners to form two new compounds. And there's usually something else that's going on here. We get two compounds that react in solution, so while they're dissolved in water, and when they are dissolved, what they do is they can produce a precipitate, which is a solid that doesn't dissolve, a gas that will bubble out, or a molecular compound like water. And here is our example reaction. Silver nitrate plus potassium chloride gives me silver chloride plus potassium nitrate. So what you can see here is that this side I have 1, 2, and on this side I have 1, 2. So it can't be synthesis and it can't be decomposition. But if I look here, AgNO3 tells me I have a compound. KCl, a compound. And then a compound and a compound. I know right away it is double replacement. But if I just want to make sure, I can actually double check. Here I have Ag partnered up with my NO3. If I look at the other side, my Ag is here, but my NO3 is partnered up instead with the potassium. And here on this side, the potassium and the chlorine are paired up. So you can see here how they kind of switch partners. Now the reason why they are written that way, and the reason why the silver and the potassium can't partner up, is because both of them are positive ions. I won't have two positive ions actually come together. It doesn't work that way. So when I'm writing the compound, I need to make sure that the positive ions are written first. And you are going to be able to need to be able to identify all four types of these reactions. So what I want to do is very briefly walk you through the first four examples there on your Classifying Chemical Reactions worksheet. And we'll take you through the process here. All right, so let's take a look at the first one. I have KClO3 giving me KCl plus O2. The first thing I always do is count. So in this case, I have one reactant and I have 1, 2 on the product side. Now that actually matches up with our pattern for decomposition. So we're done with that one pretty quickly. This one I have 1, 2 on this side and I have 1, 2 on that side. That does not fit the profile for either synthesis or decomposition because I don't have a single 1 on either side. So now I actually have to look. HCl is a compound. NaOH is also a compound. And on the product side, I have a compound and a compound. So I have two compounds on both sides, and that is double replacement. I'm just going to write double here. Let's look at number 3. I have 1, 2, and 1, 2. Again, that rules out synthesis and decomposition. So let's take a look at the makeup. This is an element, magnesium, and a compound, HCl. On this side I have a compound, Mg and Cl, and an element. That is the pattern, or that is the profile for single replacement. Do you see, by going through the same process over and over, it helps me rule out ones that it can't be, and that actually helps me make my decision faster. Okay, number 4, I have 1 reactant, 2 reactant, and I have 1 product. Since I have 1 on one side, I know it's either synthesis or decomposition, and the definition of synthesis is I have 1 product. So this is synthesis. Now, this gives you some other reactions to actually practice going through. Once you get the hang of this, this is actually pretty easy to do, but the answers for this will be up on Moodle.